Hi, I'm Tina from Prep 101. In this video, I'm going to review trig graphs and special triangles. Both of those are important throughout the course when we do derivatives and antiderivatives. Okay, let's get started. Okay, so the first thing we're going to look at in this video is the graph of y equals sine x and the graph of y equals cos x. So if you remember your graphs, you can draw a quick sketch. Sine x starts at 0, 0. Goes up to 1 at pi over 2, goes back down to 0 at pi, then it goes down to negative 1 at 3 pi over 2, and then back to the middle or to 0 at 2 pi. And so that's a quick sketch that you can draw of y equals sine x. And of course, you can continue it into the negative as well. Y equals cos x is the same shape, but it starts at 0, 1. So that's our starting point. We get down to 0 at pi over 2, down to negative 1 at pi, back up to 0 at 3 pi over 2, and then back up to 1. So its shape is kind of like that, between 0 and 2 pi. And y equals tan x, the last graph here that we're going to look at, has 0, 0 point. It has asymptotes, so lines that you don't cross, at negative pi over 2 and pi over 2. And then, of course, it gets closer and closer to both of the asymptotes here. And so, when you're evaluating, let's say, a derivative or an antiderivative, you might have to evaluate it at a number from a graph. So if, for instance, I ask you for the sine of pi, then you would make a quick sketch of your sine graph and look at the sine of pi here would be 0. And so we would write sine of pi equals 0. If we looked at, let's say, cos pi over 2, then we would look at our cos graph, which is the second graph here, and cos pi over 2 would be equal to 0 there. And let's say we were asked for sine pi over 2. So look at your graph, and what would sine pi over 2 be equal to? So we look at this graph, and sine pi over 2 is equal to 1. And if we look at, let's say, tan of 0, well, our tan graph is right here, and the tan of 0 is equal to 0. So let's do one more, sine 3 pi over 2. So look at your sine graph, and what would be the sine of 3 pi over 2? So sine 3 pi over 2 is down here at negative 1. So those are just examples straight from your graphs that you could get for either derivatives or antiderivatives during this course. So the next thing we're going to talk about is our special triangles. And for special triangles, here's a picture of what they look like. There are two that we talk about. So the one with pi over 3 at the bottom and pi over 6 at the top. So this triangle, I just draw it like this. And so we've got, if we want to draw the triangle here, we would have root 3, 2, 1. And this would be pi over 3 at the bottom, and this would be pi over 6 at the top. So that's the first special triangle. The other one's a little easier because both angles are pi over 4. So this one, the angles are both pi over 4 at the top and bottom with the right angle here, and the sides are 1, 1, root 2. So again, if you want to draw that triangle, 1, 1, root 2, and both angles are pi over 4, but you only really need to work with the bottom one there. So again, we can look at lots of examples of what they might ask you on an exam. So, you'll get a derivative, and then let's say you have to evaluate the sine of, pi over 4 or something like that. So if we have sine pi over 4, well, we know that from SOHCAHTOA, sine is opposite over hypotenuse. So if we look from pi over 4, opposite means go across the triangle. So that's opposite, and hypotenuse is always across from the right angle. And so opposite is 1 over hypotenuse is root 2. So we get 1 over root 2 for sine pi over 4. So if we want cos pi over 3, what would we get? Well, let's practice drawing your triangle. So root 3, 2, 1, pi over 3 is at the bottom. And so cos, SOHCAHTOA is adjacent over hypotenuse. So from pi over 3, the adjacent is the touching side. So it's touching the pi over 3, and hypotenuse is always across from the right angle. So we get 1 over 2, or 1/2. And if we look at, let's say, tan pi over 4, well, let's draw the pi over 4 triangle. It's 1, 1, root 2, pi over 4. And if we're looking at tan, we're looking at opposite over adjacent. So SOHCAHTOA, so opposite over adjacent. From this pi over 4, opposite means go across, and adjacent is the one touching the pi over 4. So we actually get 1 over 1, so we would just say 1 for that. Okay, let's do a couple more. If we do tan of pi over 6, then we're looking at the root 3, 2, 1 triangle. So again, just keep practice drawing them until you've memorized them. Pi over 6 is at the top, pi over 3 is at the bottom. So tan of pi over 6, tan is SOHCAHTOA, opposite over adjacent. And so from pi over 6, we're looking at from up here. So opposite is go across the triangle. So the opposite from pi over 6 is the 1. And the adjacent, the touching side to pi over 6 is the root 3. So we get 1 over root 3. And let's do one more. Cos pi over 6. So SOHCAHTOA, cos is adjacent over hypotenuse. And we've got the triangle right here. So the adjacent side is root 3. And the hypotenuse we know is always across from a right angle here. So the hypotenuse would be over here, which would be 2. I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.